Okay, everyone, let's practice a bit more. Let's consider this scenario. A pool is filled with 11,112.5 gallons of water. It begins leaking at a constant rate per minute. Okay, we know the rate of change is constant, so we know this is a linear function, and it can be represented by a line. After 15 minutes, 6,350 gallons remain. Finally, the pool is empty, that is, 0 gallons remain after 35 minutes. By how many gallons per minute was the pool leaking? Darn it, that is not spelled right there, is it? How many gallons per minute is the pool leaking? That means what is the rate of change? We want to find the rate of change of this linear function, which also means we want to find the slope of the line that we use to represent this linear function. Well, we know we have 3 data points, right? We know the pool began with 11,112.5 gallons of water. At that point, x is equal to 0, right? The number of minutes since the pool started leaking is at that point equal to 0 because it hadn't started yet. So we know one data point is 0, 11,112.5. After 15 minutes, 6,350 gallons remain, right? So we know we have one data point where x is equal to 15 minutes after the leak began, and the y value is equal to 6,350, the amount of gallons left in the pool at that point. And we know we also have a third data point, right? We know that this data point is 35, 0, which means 35 minutes after the leak began, the pool is empty. That means the y-coordinate is 0 because 0 gallons remain in the pool. All right, so there's a couple ways to find the rate of change in this scenario. Let's make some room for us to work here. Let's make some room. There we go. So remember, we can take any two given points, right? And we can calculate the change in the y-coordinate divided by the change in the x-coordinate, or the rise over run, right? Or the rise over run. And we can pick any 2 points, and we'll always get the same answer, right? That's what it means to have a constant rate of change. Let's pick this point and this point, okay? Let's have x1 comma x2 be 15 comma 6,350, okay? Because I keep writing x1, x2. That's not what I mean, right? I want x1 comma y1, right? The point with our first x coordinate and our first y coordinate. Whenever we're calculating the slope from 2 given points, we always want our first point to be the one with the lower x value, okay? And then we can have our x2 comma y2 be 35 comma 0, okay? And now we want to go ahead and calculate the change in y divided by the change in x, okay? All right, let me get my drawing point back. So that means we want to calculate y2 minus y1 divided by x2 minus x1, okay? And y2 minus y1 is actually 0 minus 6,350, right? 0 minus 6,350. x2 minus x1 is 35 minus 15. Okay, let's calculate that. 0 minus 6,350, that's pretty easy. That's negative 6,350 divided by 35 minus 15, that's 20, right? And let's see if that makes sense. What should the change in our y-coordinate be from 6,350 to 0? Clearly it decreased by the whole 6,350, right? So the change was negative 6,350. And what's the change in our x-coordinate from 15 minutes to 35 minutes? What was the change in time? Well, time changed by 20 minutes, right? So our change in x should be 20. Now let's just calculate negative 6,350 divided by 20, and we get our answer to be negative 317.5. All right, so negative 317.5 is the slope of this line. Therefore, negative 317.5 is the rate of change, which means, let me get some room for me to write this statement. Let me get some room up here. What does this mean? Well, it means that the pool is leaking at a rate of, it means the pool is leaking. It's leaking 317.5 gallons per minute. Rather, I should state it like this, which means the rate of change, or M, is negative 317.5, right? Does it make sense that it's negative? Because if we have a downward moving line, right, that means the slope is a negative number. And since the pool is leaking, the number of gallons inside the pool is decreasing every minute. It should make sense that our rate of change is negative, right? Let's do one more example with two different data points, just to make sure we know that any two data points we pick will give us the same answer, okay? We just want to make sure of that. Let's pick in this case our first data point, okay, and our second data point. All right. Now remember that when you're choosing what your first data point is and your second data point is, therefore what your x1 comma y1 is, you want your first data point to be the least x value. So in this case, x1 comma y1 is 0 comma 11,112.5, right? And our second data point that we're going to use is going to be x2 comma y2. That's going to be 15 comma 6,350. All right. So now let's just calculate y2 minus y1, the change in y, divided by x2 minus x1, the change in x. That's going to be 6,350 minus 11,112.5 divided by the change in x. That's going to be 15 minus 0, right? Okay. What is 3,650 minus 11,112.5? That's negative 4,762.5 divided by what's 15 minus 0? That's just 15, right? Okay, and kind of running out of room here, so let me just write equals here, okay? So let's calculate that. Negative 4,762.5 divided by 15. We get what we want, right? We get negative 317.5, right? The same rate of change, which is what we want because this is a linear relationship. So the rate of change is constant, okay? Between any 2 points, the rise over run or the change in the y value divided by the change in the x value will always be the same. So as long as you have two different data points for a linear function, you can always find the rate of change of that function by calculating the slope of the line that connects those 2 points. Okay, let's do one more example so we get more practice with calculating, okay? So let's say we just knew we had 2 points on the graph of a linear function. One point was 13 comma negative 8. The other point was 2 comma 51. What is the rate of change of this function? Okay, we know we can find the rate of change of a linear function, right? By finding the slope of the line that we use to graph that function, right? So what is the slope of the line that will connect the points 13 comma negative 8 and 2 comma negative 51? All right, so we know we have to calculate the change in y divided by the change in x, right? Which is y2 minus y1 divided by x2 minus x1, right? Okay, so let's figure out what should the point x1 comma y1 be. Should it be 13 comma negative 8 because it's the one written first? No. Here's where we have to be careful, right? We always choose our x1 comma y1 point to be the point with the lower x value. So x1 comma y1 is going to be 2 comma 51, right? And x2 comma y2 is going to be 13 comma negative 8, okay? All right, so Let me make some room here for us to calculate. Let's make some room here for us to calculate. There we go. Let me get my brush back and my color back. Okay, so what is y2 minus y1? y2, not g. y2 minus y1 is going to be negative 8 minus 51, right? Okay. And what is whoops, let me organize this a little better. All right, there we go. y2 minus y1 is going to be negative 8 minus 51. And what's x2 minus x1 going to be? It's going to be 13 minus 2, right? Okay, what is negative 8 minus 51? Negative 8 minus 51 is negative 59, right? Negative 59 divided by 13 minus 2 is 11, right? There we go. I mean, if we wanted to, we could keep it like this, right? There's nothing too bad with a fractional answer. Or if we wanted to, we could write it as a decimal, which would be about, let me get a little bit more room here. It would be just about, it'd be just about negative 5.36, okay? But there's nothing wrong with the fractional answer either. So that would be the rate of change of a linear function which had these 2 points on its graph.